Hello guys, today we have another episode and we are super pumped and excited to talk about Trino, right Matheus?
Yeah, and we have like a really special guest, so guys, stop what you're doing and listen to this guy. Brian, can you introduce yourself?
Yeah.
All right, well thanks for that introduction. Yeah, my name is Brian Olsen. I'm a developer advocate. Software engineer before this, that was working really heavily in the, Trino at the time was still called the Presto community. And so we'll get a little more into that later. But we've just been, doing this for about, 6 years now in the working on this project, and it's been great. Learning all the things that I've learned about query engines. It started out as something I was using, and now it's something that I'm kind of very heavily involved. And at this point, I've kind of taken a step back from the kind of engineering stuff as much, other than helping engineers on board and giving them demos and tutorials. I'm now trying to focus on like how do we spread the word about Trino. I think there's a lot of confusion. Particularly around some of the community stuff that we'll get into here today, and I'm really excited to talk about that. Other than that, previous to being a software engineer, I was a Marine. I did 6 years in the United States military, and that's actually where I kind of got into computation as an interest. We did a lot of networking stuff there, but we interfaced with a lot of cool technology in the military, and we were tracking different people going across borders in Iraq and stuff like that. And I saw databases and things like that, being used, and I thought, wow, I want to understand what's going on behind all of this and what actually kind of enables us to do all this crazy, cool stuff, and I guess fighting terrorism and whatnot. So I that's kind of what piqued my interest. And now I just, when I got into my CS school, I just really thought databases were incredible. And this was right around the time Hadoop was getting really big. I started doing research there with a professor, and I just fell in love, and I couldn't go back.
Wow. And dragged you now to Trino. So that's a pretty fantastic background, and look at this perspective to the database and the importance of the database in the real use case, right? So I think you lived that. You were able to see how that happens. But I think you mentioned something about the origins in Presto and Trino. So I would like to kick off this episode by asking the first question around what's the story behind the Trino, and because we had seen a lot of traction on Presto, and then all of a sudden, for people that is expecting or seeing that things on the news, we saw Trino. And what happened behind what's the morale of that? What's the story?
It makes sense to go back all the way to when Trino was not Trino. So Trino actually started out as it is an open source project that started out by four gentlemen. Martin Traverso, Dane Sundstrom, David Phillips, and Eric Huang. These three, the first three, had a long history working with each other at other projects, and they've used a lot of these, kind of big data warehousing technologies at these other things, kind of like Teradata, and basically these. What is the other one I'm trying to think of? Netezza, and so. They saw some of these things like Netezza that were like, these kind of full level customer level, like, enterprise software that has just a drop-in solution that just works, and they looked at what the current state of the art was in open source, particularly around Hadoop, and around 2012 they were moving into Facebook, and at that point Facebook had been 4 years since Facebook had released the Hive project around Hadoop, so that you could kind of run SQL-esque type queries on your data warehouse, but it was just really crappy and slow. Things were just never working. Like, it always was like this real big struggle to kind of, you had to understand exactly the version you were on. There was constantly version incompatibilities. Like, you usually just had to like build your own Hive to kind of like, make it work. And so it wasn't this kind of drop-in solution that they were seeing in kind of enterprise, that they just were like, well, that's something that it just really sucks that nobody has that. Nobody that is in the open source trying to use this stuff. Hadoop was just blowing up at that point. Everybody was storing their data in there, but they really couldn't make use of it. There was this high amount of demand for like people that could write MapReduce jobs all of a sudden, and then they just, some people I'm sure knew how to write it, but I'd say 80% of the people writing MapReduce whenever that was really big was like nobody knew what they were doing, or didn't know how to write non-buggy MapReduce code, right? And so we ended up with a lot of this really broken pipeline software, really broken kind of ways, and people were just struggling getting data out of Hadoop. And so, this same problem wasn't sparing from the big, giant megacorps in the Silicon Valley either. Like Facebook was also, running into problems like this in their data warehouses. They had their own Frankenhive. They had this giant MySQL farm, and they were constantly struggling getting that data out at scale and being able to, run. In fact, there's a common anecdote going on at Facebook at the time, which was saying this is from some of the data scientists. They're saying it's a good day when I can run 6 queries on Hive. So this was the problem that we were facing at 2012, and that's like just to bring everybody back, because I feel like we're in today's world where there's just so much commoditized. Like the problems in data engineerings have like been sliced and diced into so many smaller solutions now, versus Hadoop was just this monolith of like everything in one, and Cloudera and Hortonworks were trying to like make that work. But now there's like a million businesses around the smaller problems, and people are solving those in a much more, I would say more, much more fuller capacity than they were, when they were trying to, one company trying to do everything. And so,
yeah, I couldn't agree more.
So it's kind of like, we were struggling. At the time, it was like a huge struggle for you to be able to kind of get anything done. So what these guys were doing is, okay, we just want there to be a drop-in solution for you to be able to query this MySQL farm, or be able to query over this Hive data source. So they wanted to come up with a system that ultimately would replace Hive. It was the first primary goal. So first goal, let's just replace Hive and see what goes from there. And we're going to have to basically write this query engine from scratch. We wanted to utilize the same, be able to run on top of a distributed file storage like HDFS, or in anything else really, and probably take advantage of the existing metadata inside of the Hive metastore. So that was the first real okay, let's say what we're doing, what we're not doing, and what they were doing at the time was replacing Hive. So that was 2012. They basically go out and write this system, and the big thing that they started emphasizing from the beginning was, we need to make this open source because we decided we want to make this a project that doesn't just solve a Facebook need, and I want this to be something that we're going to dump a lot of our time and effort into, because we don't want it to be something that stays inside of Facebook and then just only serves a Facebook need and then dies away. And at that time, Facebook was getting a lot of, good press and all this other good stuff around open compute. They had recently done that and kind of disrupted the hardware industry. So it was very easy to at that year to be asking Facebook, hey, can we open source something and make this? And it was very trendy, especially, even now Facebook has a lot of open source initiatives, but back then it was I think that's where a lot of that trajectory started. And so they got the okay to kind of open source Presto, and they took about 6 months from beginning of the project to actually releasing the first version into production at Facebook. Following that, it was about 4 months later, they open sourced it and started opening this up and they did a couple private betas, but then they opened it up to a couple more companies like Airbnb, LinkedIn, and Netflix, and started pulling them all in and trying to ask them if they could start running Presto on their systems. And so they started getting requests, like Netflix in particular. They run totally on the cloud. So that was already the first time where they had to adapt Presto to be able to run in a cloud environment on, against AWS. And this is, by the way, when, S3 was just like a very new thing, like nobody was on the cloud yet either. So this was another kind of, I think, foothold to, Presto's early success, is that it started opening up immediately to more newer use cases that at the time were just, on the bleeding edge of what people were doing.
Pretty niche. Also,
yeah, it was very
niche. I think pretty niche.
Yeah, like not like everybody was like, no, you run on your own HDFS.
Yeah.
You don't want to give that to the cloud. You don't want to give it to Amazon. So then basically fast forward a couple of years, so Presto starts taking off once like all these Valley companies start talking about their, they're able to scan petabytes of data in seconds to minutes. And, everything is correct. They're following this ANSI SQL standard, making sure that we're not falling into the same traps that we did with Hive, where we're like running these like, SQL-esque queries, but they're going to have their own style to them. You have to actually look up the syntax every time. No, this is going to follow like a much more standards-based type approach when we're building this. As things moved on, fast forward to 2018, the trajectory of the project's getting huge. Like people outside of the Valley are starting to adopt it. Finance companies are starting to adopt it. Amazon creates Athena, and Athena under the covers is branched off of a older Presto version, and they've done their own thing with it now, kind of connecting it to other Amazon specific databases. But under the covers, the core engine is Presto. And so we get to about 2018, and Facebook kind of does not, essentially wants to have a little more. There's a lot of politics going on, I guess, in the background, where people in Facebook, they essentially have like to work on stuff to basically get a little bit of essentially work under your belt. I've never worked at Facebook, so this is very hearsay. I don't. If anybody, have either of you worked at like any of these bigger companies or heard of this horror stories? Apparently, you have to like constantly be showing like stories. Yeah, like you have to.
I love it.
So the problem was like people were having to kind of show, hey, I'm doing this work, I'm getting stuff done, and you have to move fast. Well, Presto, being an open source project, it moves a little bit slower, especially when it comes to like somebody who, let's say, is brand new to the project, who just joined Facebook. That person is like another community contributor. They're not special because they work at Facebook as in an open source project, and that's how Martin, Dane, and David had run this from the beginning. The problem was Facebook wanted these people who needed faster capabilities to just iterate and do stuff for Facebook's needs. They needed them to be able to iterate faster. Ultimately, there was a decision from like higher level management to say, you know what, we're going to give these people automatic, like committer privileges so that they don't have to do all the open source legwork. And this doesn't sit well with Martin, Dane, and David. They want people who, to have committer rights, who know the project, who've been there, who understand the quality to make this Presto what it was already even at that point. It needed to have a level of quality checking and making sure that there is a level of maintainership there. And so, go ahead.
No, just to put it simple, I'm just trying to sum it up things here. So we are talking about just being this decision about moving between Presto to Trino was more inclined to politics rather than the technology that was running behind the scenes.
Yeah. Unfortunately,
it's fair to say that.
And this is kind of you saw similar things like, I don't know if you guys ever followed like Jenkins project, right? The CI, and they had a very similar problem when Jenkins was called Hudson, and they Sun had the same problem. They wanted to be able to iterate faster for the company's sake, and people the community split off and made its own fork. This is the exact same like repeat of what we're seeing in those types of open source, kind of dramas. It's like the company wants to have their ability to iterate on their own thing, which is fine, make that an internal thing.
Yep.
But it's not. It shouldn't be kind of imposed on. If people come to the project thinking this is open source, this isn't going to be meeting just the needs of Facebook or one specific company. This is to meet my needs, and this is why I'm going to contribute my time. If you come in with that kind of context, thinking that that's what you're contributing to and you're spending time on, that's how you need to continue running the project. And that's what Martin and David did. They split off the project at that point. They formed a similar project called Presto, because essentially what the managers were saying is we don't want to do the open source thing for this anymore. We want this to just be a Facebook project.
Let's branch it out and call Trino, and that's it, right?
Well, I wish it was that simple. So
I know.
So it's essentially, they split off. They wanted to keep, the momentum behind the name, so they called it PrestoSQL, and PrestoDB is the one that kind of was with Facebook, right? And so what the assumption was is that PrestoDB was going to become kind of the Facebook-owned one. It was going to live in the open source code, right? It's going to be open and people could use it if they wanted to, but it was just not going to take any trajectory or any kind of thing. And then they were going to do PrestoSQL. And kind of a strange norm-breaking move, the people at Facebook decided to donate it as a Presto to a foundation under Linux Foundation. Linux Foundation automatically does this thing where they trademark anything that they own. So with that trademark, we then had to go away from the Presto name and readjust it. So 2 years after we did the split, we essentially we were forced to do a rename very quickly. And unfortunately, this came down faster than we had expected them to push on this, because we had to really fast update all of the names inside of the the Presto project. Everything that was Presto we had to rename to Trino, and this was done.
Replace, done.
It was exactly. So fast forward now to this spot we are at now. We rebranded to Trino back in late 2020, in December 2020. Right. Yep. And so we've been almost rebranded for about 2 years. And so split for 2 years and almost rebranding for 2 years at the end of this year. And so, it's been great. And in fact, I will say the rebranding was one of the best things that was ever forced upon us, because it has helped a little bit in people understanding that these are two different projects now, that essentially, unfortunately, there are companies that take advantage, and I'll just say it. It's there's a HANA company that is now taking advantage of the fact that there was the situation that happened, and they basically made a SaaS thing around the old Presto that is more, again, Facebook-driven project. They're kind of capitalizing on the name and just kind of being there in that sense.
Using that to pivot, yeah.
And it makes sense, right? Somebody's going to come in and try to jump on this situation and make some advantage to them. I mean, it's money.
It
right?
happens.
It's capitalism.
Yeah, we know the story. Yeah, it's capitalism. It's how the story goes, right?
Yeah. So then, Martin, Dan, and David, they actually go off and they're just doing the Presto. Initially, 2019, they were doing Presto for that whole year. And then later on, they just decided, to join the company that I work at now, is just Starburst. They joined after a year of just working on the community, trying to do grassroots organic stuff, and getting people moved over from the old Presto project into PrestoSQL. And try to get them moving on to, essentially build up, see what people want, start focusing in on the use cases that they have, and building out real things that they need. So the first thing that they did was hey, timestamps are a really huge problem in Presto.
It is.
Can you fix that? Well, yeah, I guess it is, because it is still on the Presto side. And in Trino, that got fixed, the very first thing that everybody was asking, hey, timestamps, we've been trying to get this, this prioritized. So first thing they do is start prioritizing timestamps. Next thing they move on to is various different push downs that they were trying to get implemented for the longest time, so that you could have more optimal speeds, things like that. Iceberg connector landed shortly after. That ended up getting ported actually over to the Presto by Twitter, and then we started then focusing on more things recently, native fault tolerance, being able to turn on fault tolerance so that you could run similar to Spark-like workloads.
We're gonna talk about it. Yeah, I just put it here. The
sure.
tardigrade, right? Stuff.
Yeah. Let's talk about that. Okay. So anyway, that's basically. I know that's a lot. I wanted to embellish the story a little bit. I'll try to give shorter answers from now on, but I wanted to give you all a very full context on terms of how we got here and why the names are so confusing.
No, I think it's spot on, because in the end of the day, what we're going to do is that we're going to pick the episode and we're going to cut it out in different, scenes. So this way we're going to be able to tell the story. But I think having this override is pretty fantastic. Yeah. And last question about this before we close off that. Is there any specific reason? Because of the Trino name, the Trino? Is there any reason where it comes
Why
from?
Trino? Yeah, so, I mean, we were struggling with a name for the longest time. It's actually... So people always joke around because why'd you use Trino? Because I could always screw up this pronunciation. Is it Trino or Trino?
Yeah.
Mm-hmm. And then or people with the website, they go, I want Trinio. Because it's Trino.io. And so it's people, and every name that you pick is going to have some sort of pronunciation gap depending on what country you're in even, so,
Sure.
The Trino came from, the shortening from neutrino. You have to find something that doesn't have handles everywhere and that doesn't have an overlap in search engine results. And so, we have a lot of kind of celestial star type stuff we were thinking through. We were also thinking about calling it TacoDB just to be totally random. We went through so many just crazy iterations trying to think through what the name would be, and at the end of the day we needed a couple things. We were trying to focus on what's important. One, we want something that can be easily found, right? In terms of awareness, in terms of being
should be sticky also, right?
It should be sticky also, and have a little bit of a story to it, and yet should also be unique enough that you can kind of easily get the handles out there on the internet, so that people it's distinguishable. And so that's a hard challenge. And it also needs to be short, right? You don't want it to be this giant, long name, because that's going to suck for the software, right? Yeah. So we needed to be short, something that's kind of almost like a child, Google is always, people think it has to be childish kind of name. So it needs to be all those things. And so you're kind of going through, throwing these things on the wall. And finally, Neutrino kind of had a bit of a interesting thing to it, but there's too much neutrino stuff, right? Neutrinos are these particles that are super fast, and so shortening that, we were well, what if they just take out the new? We could even do kind of plays on that, new Trino. It's the newer kind of thing, and so we took out and looked at Trino, and that was one thing that we put out there at the meeting. Now, I ultimately wasn't at the final decisions. I was there just trying to throw names at the wall and help out the creators come up with a decision. So it was ultimately Martine, Dane, and David's decision, and they were just sitting around drinking, according as the story goes, having some beers and just trying to think which one do we go with. And finally, they just really after mulling it over, Trino really stuck out to them. The neutrino kind of tie in with the particles thing was really a speed thing. We needed that to be conveyed. When you look up Trino and all the websites that you can get, all the handles, it's all there. TrinoDB, was a short enough one. We also thought TrinoSQL, but it's both of those are technically inaccurate. It's it's fine. It's we just needed to go with something that is available everywhere. And so TrinoDB is very much available everywhere, and Trino.io is also available as a website. So that night they booked the Trino.io website. They started grabbing the handles, making sure they had everything, and then that was it. It was Trino, and we got the word back, and we started working on the branding and all that stuff. So.
And I must say that the first time that I looked over the site, I must say that was crazy, because I saw a bunny outside of the earth, and I thought, what the heck is that?
Yeah.
It seems to be pretty fast, wicked fast. And then when I put first spin, I started to test, it was crazy, and I was so happy because of that. But, that always tied up to my mind to say, oh my God, it's a bunny,
So the bunny works on so many levels, let me just tell you. So, the bunny, originally, we were trying to think of a magic theme spin-off. So we actually, now PrestoSQL is a sub-project of Presto now that they're doing another thing with. But we actually thought of using the brand PrestoSQL, but we didn't want to upset anybody in the Presto community by doing that. So we just decided that was not a good move. But we thought, what if we did something with the same, Presto's a magical term, right? With the Presto, Alakazam type words. So we thought, and it's also a fast word, So it's like we wanted to stick with that maybe magic because, sometimes it feels a little magical how fast Trino is and Presto is. So we thought, what if we stuck with that magic theme? So we started out getting a couple, we have a UX UI designer here, and she started creating the bunny. And so it was the bunny coming out of the hat as kind of like one of our logo ideas. And then when we decided, we don't want to call this magic because it's actually not magic. It's awesome engineering, right? So we went away from the magic theme. And we just decided, but bunnies are still fast, right? You have to, you don't want to go with the tortoise and the hare thing. We're not the complacent bunny, but we're just the fast bunny that knows that we need to keep running.
Bunnies are, let's put it this way. Bunnies are fast in so many different ways, right?
Yeah, that's right. And we'll leave it at that. So, and
you know what I mean.
Yeah, gotcha. So we'll keep it to the PG version, and we'll say it's the tortoise and the hare, where the tortoise keeps running. But hey, in a distributed manner, you could say they keep replicating, more workers and stuff like that. And so, anyways, so getting back to the bunny theme, we decided it's really good to keep the bunny, right? Because bunnies are fast, it's super cute, it's something that we wanted to take away that whole element of database projects where it's we're so serious, we're so cool, you'll never be able to learn us.
40s, we're so 50s, right? Because database systems are back on them and still being progressed and still evolving. So I think we would like to brand in a way that should be fashionable, swanky, new.
Yeah. And if you look at the Presto logo, it's it had a very abstract logo to it. It's the cursor, right? I don't know if some people don't notice that, but it's the cursor, and it's just if you're not into databases, that's not a thing you can connect with. And your kid, if you have a kid, you're like, hey, look, I'm into Presto, and they're like, I don't give, that's a bunch of dots, or I don't know what a cursor is, I don't care. But now I have these little Commander Bun plushies that my daughter freaking loves, and it's just and anytime that she sees, I dress up as Commander Bun to do the intros to our conferences and stuff, and she's like, my dad is practically this giant bunny thing, and so it's that, having that ability to have people relate and have people connect and be a more open community is something we really wanted to convey with that. And we don't want to be this scary database project. We want to be this open, inclusive, welcoming space that people can actually learn these fundamentals, of distributed computing, of query engines, of database theories. And we don't want people to feel oh, this is a very scary, intimidating database project.
And for the outside perspective, I would say that you guys are pretty much spot on. You hit the nail in the head. I mean, the first impressions are what you stick with, right? And the first impression with Trino was flawless, was breathtaking. I would say that I used to follow Presto, used to use Presto and Hive a lot in my day-to-day. Yeah. And then when I flipped over to Trino, it was crazy because of the advance of Kubernetes and all the stuff that we're going to talk here as well. Yeah. So, let's move along. Sure. Before we get into the Trino stuff, I would like to understand a little bit about your thoughts and imaginations about data virtualization stuff. Let me tell you why. Let me just bring a little bit of context on this. So we've seen a lot of, traditional data warehouses, then we moved to modern data warehouses, and then I think I don't recall the time specifically, but I do remember that in 2014, 15-ish, someone brought up the term data virtualization. Yeah. And then that thing started to pretty much spread out a lot of companies, and I think most likely a lot of Presto and stuff like that too. How do you not copy the data over and do ETLs all over the place, and you reduce the friction by having people tap into the data pretty easily? Yeah. But what do you think about the data virtualization? Because in my opinion, it's gaining so much traction in so many areas. We have a course, we have a training in Brazil, where we talk about the different facets and the different data virtualization tools. We have Polybase, we have Athena, we have Presto, we have Trino, and we have a variety of those. Have you seen a massive and huge adoption of data virtualization nowadays to solve silo problems, solve the ecosystem problem, and how these, ties up with Trino?
Yeah, so I'll go out to say actually data virtualization has been that particular term has been around since the 90s, and data it was actually a big point of research in kind of more late 80s, and it became more of a general use term in industry in the 90s, and people started trying to implement data virtualization very early on. But there were these really crude attempts at it, and this is why you don't really know about it today. Is like it didn't really take off, and the reasons why is how they approached data virtualization in the 90s was, and even still today, there are companies like Denodo and I think there was one more that probably maybe died off, but Denodo is like the kind of well-known data virtualization technology that's been around for decades, and what they're trying to do, or what they tried to do, and how they tried to solve the problem is essentially let's like talk about the problem that data virtualization is trying to solve. Yep. The data virtualization is basically like you have, we're dealing with the problem of like, okay, we have a database that can kind of do really well at this type of problem. We have another database that's kind of doing really well at this type of problem. And so actually the earlier versions of this was like we have an OLTP database. We have, so this is going to be transactional. This is kind of the traditional relational databases that you kind of have in your head. Maybe at the time was DB2, but more frequently nowadays it's like MySQL and Postgres. And then like you're also going to have like OLAP systems, MOLAP systems, and all these different types of like analytic systems. And then you also are trying to have different databases. I think like there were a lot of data silos going on for different departments. So like you might have like a sales department maintains their own database, and marketing department maintains their own database. Initially, things were split out like that. Nowadays, I don't think like any line of business person's not going to be maintaining a database anymore. But back at the time, that was very popular. And so being able to see across all of these databases was really important. So the first solution was OLAP and bringing everything into one, and kind of the data warehousing solution. But then data virtualization was like, well, what if we, kind of skip that and like having to move everything? What if we actually just, ran the query and at query time tried to solve for moving that, like essentially solving that on one system, but the person who's querying that data has no knowledge of how that actually works under the scenes. All of a sudden, they're able to connect to all of those databases and do like a single query to join across all of them, but they're still able to maintain and stay and be run on their own separate thing. Like, so essentially marketing gets to stay on their own database. They don't have to touch or collaborate with sales, right? And so this was really kind of exciting, but the problem is the way they implemented this was ultimately you had to run this computation somewhere. And so what the early data virtualization kind of systems would try to do is they would basically move data from one side. So let's say you have two databases, like a Postgres and a MySQL, let's say, so that we can distinguish them. So on your Postgres database, you're going to say, well, let's run the calculation here in Postgres, and we're going to pull the data out of MySQL, copy it over to Postgres, and run the computation in Postgres at that point. That made it virtually impossible for you to have to know that implementation detail, which is great. It gave you as the user a much simpler experience, but you still had to pay that penalty of moving the data around. And that is essentially you're writing from disk to disk. The thing that's really changed recently is that, with the whole, movement in Hadoop to separate compute and storage, and this is where data virtualization started to come back up, where in that 2015, people were like, hey, what if data virtualization started to apply with this whole separation of compute and storage? What if we just, ran everything in compute and queried all these things individually? And this is right at the genesis of like Presto was like, this whole movement to kind of bring that kind of capability back to run queries across these different data sources. But now, instead of writing to another disk, you're just streaming those calculations and those computations in memory on the system. And this was already kind of happening with Spark, but Spark and things like that were still too kind of heavy and drawn down into like, fault tolerance and trying to really focus very heavily on essentially emphasizing writing. They still had a lot of these operations that write back to disk. They run in a very blocking manner. And so it was very useful for large scale computations. But when you wanted to run something fast, you wanted to run over multiple systems, you ran into a freaking brick wall because it was
and
incredibly
there's a
slow.
problem. Yeah, and in my opinion, just the huge difference between the systems is that the Spark is not well designed and meant to understand each one of the data sources that they're dealing with. So it's pretty much optimized for file-based storage style of stuff. And Trino does this pretty beautifully because he can understand the best practices and how they extract the data for each one of the connectors. So that's a big difference between them. So they interact in the best way that Postgres, that MySQL, and that whatever can communicate with. So I think that's a big, huge thing that Trino does.
Yeah. So to close the loop on data virtualization, what Trino does is still data virtualization. We typically avoid the term because it gets kind of mixed into the old implementation style, and people go, "Oh, I've seen this before. I saw this back in the '90s, and it sucked." And we don't want to have that impression coming, about Trino. So what we typically call it is data federation. It's, again, just a different word to describe the same thing, but when they hear it's a different word, it doesn't bring those bad kind of memories of the older systems in the 90s. But it's very much data virtualization, though. Like the core use case of how data virtualization never said you have to copy data from one to the other. That's just how they did it. It was an implementation detail, and it was just before we really were embracing. All we had back then were these monoliths that had compute and storage kind of coupled together, and so that's the best we could do. Once we kind of embraced distributed computing, we embraced compute and storage were different things. Then that became a much more clear version of data virtualization, and that's why we just call it query federation. But it is still very much that.
So I think what unlocks the Trino capabilities, in my opinion, now just looking at that spectrum, is that first, the advance of being able to decouple storage for computation. And I think second, I think the reduction of the cost of the RAM, right, over the 2015, 16, and 17, because that's where Spark came into play, and then you see virtualization technologies also just
blowing up. Right? So, with cloud computation too, like it becomes way cheaper to just rent RAM than it is to buy RAM, right?
True.
So especially on a per request basis, as we're getting into more of these SaaS solutions, where you can just Athena or like Starburst has Galaxy, you can just ramp up based on the at query time, basically ramp up, use some resources, and then it immediately goes away, and you're not paying anything anymore for it. Like that's I think really where things started to change from how we architect things, how we think about running things on a cost saving type basis. It was that changed the whole game going to the cloud. So
I agree. Yeah, taking the hook of this one, and Brian, most people still learning about Trino, still understand the Trino. I'd like you to explain to them the main capabilities of Trino, like the architecture, how the connectors work, and the execution plan, how we can read the execution plan. A simple one, nothing so fancy. Yeah.
So I want to basically let's talk about I would say there's two big bucket of use cases for Trino. When you want to think about what do I use Trino for, I like these are like 99% of, or maybe that's too high, but 95%. We'll give myself a little grace period there. And so 95% is covered by one of two use cases. The first one I'll talk about is that federation use case. So, and this might be in an analytics use case where you're trying to run bigger computations over multiple databases, or this could be something where you're trying to actually run smaller computations and embed it for like an application use case. And so let me step back and kind of talk through what that is. So let's talk tangible. So one thing, a couple of connectors that Trino can connect to is the Elasticsearch is like happens to be one of the connectors. This is one of the first connectors that I used, and actually one of the first ones I started to contribute to. And so what this allows you to do, why I think this is so powerful by itself, is Elasticsearch has a query DSL that is very different. It's a search query engine, so it has to have a lot of these extra syntax. And the way that they represent this domain-specific language is what DSL means, is they are basically exposing all of these different kind of abstract concepts like Boolean queries, match queries, and things like that, and representing it in a JSON format. You send Elasticsearch this JSON blob of like your query of kind of like your query specifications, and Elasticsearch knows how to kind of take that and return to you results in a very specific way based on what you send to it. But it's nothing close to like a relational database or anything you can do with SQL. But what's really interesting about Trino is you are able to have this kind of translator. This is this layer that we have inside of Trino called the SPI, and this is the service provider interface. So it's literally this thing that says, I have a generic interface, or I have a generic contract of how I'm going to interact with the world, with databases in the world outside of Trino. And I have a list of things that I need to know about these databases to understand, where the data is, how it's optimized, how all these things. And how to translate a query in SQL to a query that this data engine is going to understand, and how I can push more of the logic of the query down into this database so that it can actually use its own internal indexes and all this cool structures. So that's what the SPI is doing. It's literally, think about it as like a translator. If you're talking to somebody who speaks a different language than you, and that person's translating for you, and they're trying, sometimes it's not a one-to-one translation. Sometimes it's like the person kind of interprets what the speaker's saying. So you have to be kind of very, fluid. And so Elasticsearch doesn't have a perfect model to relate to a relational database like SQL. So we have to take some leniency there and figure out hops. Yeah. But for the most part, it pretty much just works. If you want to be able to query a system like this, and then let's say you're going to query a more like let's say traditional system like Postgres, and you want to actually talk to that system, well, those are SQL. That's practically kind of like a SQL to SQL thing. So that's great. But where the real power comes in is like, I can actually talk to data in a maybe a table. In Elasticsearch it's called an index, but a table roughly sitting in Elasticsearch, and then I could talk to a table sitting in Postgres, and I can actually, in the same SQL query that I send to Trino, run a query that pulls data from that. Actually can, maybe if I have a where clause on something, it's going to push that where clause down to each of these systems to make sure that I'm getting as little data back to answer that query as possible, so that I'm sending as little data over the wire as possible. Once that data gets to Trino, and here's the big difference, we didn't have to send any of that to either of the other databases. It just streams into Trino. Trino then has a distributed in-memory worker nodes that will then process that data and return the results to you, whatever processing has to happen. And usually it's like joining the data on some column. And so this is, for me in my previous job, we had exactly the system. We had, instead of Postgres, we had Hive. We had big data that was stored for over a year, and data stored in our Elasticsearch that was stored for 90 days. And we needed to be able to give a customer a coherent view of that 1 year view of that data. So we could actually query Elasticsearch, query Hive, and pull out that whole year of data for that specific customer and only scan that special amount of data and then get it streamed to Trino. What we had before this was this super flaky, janky service that we had to update every single time there was a change in any of the fields or all this stuff. And with Trino, it was just automatic, and anytime there was a change in the schema, that's all we need to do is update the schema and then track that in CI, the change GitHub somewhere, and that was it. So that is one of the very core use cases, that federation use case, being able to query the data where it lives, so that you're not having to basically do this thing where you're centralizing it in a warehouse, or you have to know all these different, query languages. If you are a data scientist, you could literally talk to Elasticsearch, Mongo, Hive, Snowflake, all of these different connectors from just one query syntax in one location, and you don't have to showcase your whole entire, from a data engineering perspective, you don't have to show that entire complex system underneath to your data consumers. It's literally just like, this is my world, I see Trino, and that's it. So that's
as you speak, I'm still getting goosebumps because because it's crazy. I mean, I've been dealing with data for the past 14 years.
Yeah.
So I started with the database background, then I moved to NoSQL, and then just with general big data systems and distributed systems as well. And when you see the magic, it's not magic, of course. It's a pretty beautiful data engineering process that happens behind the scenes, but it seems magical, because it's freaking fast. Yeah. It's freaking fast. Yeah. And it uses the best of breed of technologies behind the scenes, JAWS, serializations, just logics behind the scenes, a pretty neat query execution plan, and the whole shebang to make your query run fast. And it's crazy about how much push down computation all the connectors can actually apply. So if you look about the query engine per se, you're going to see there's a bunch of push down happening. And that's insane because we know how hard it is to make push down effectively, especially with data files, especially with some databases. It's not easy. So having this context that interprets each one of the data sources it's not magical, but it is fucking awesome, right?
Yeah, it's great. So that's the big one I like to talk about first, because sometimes we lead with our second one that I'll talk about, because this is historically where it came from. But the other one was that I told you initially that Trino was created to replace Hive. Well, it kind of it started that way, and now it's become into this. So Hive was kind of the OG data lake, right? Before we knew what a data lake was even. It was kind of like, they called it a big data warehouse, and it really wasn't that, because people were just throwing giant files in there, and it was essentially what got coined as the term data lake. And so what Trino ultimately ended up becoming was a data lake, what we call today a data lake query engine. And so that is kind of another very common use case, is that people who are trying to go away from Hive, who are trying to kind of get off these slower architectures, and it's still, despite all the hoopla and talk about, Iceberg and all the newer formats, and that everybody is, or moved on to Redshift and BigQuery and all this stuff, there's a lot of people in big data and in data engineering that are still using Hive, and and so to be able to get those people to be aware of Trino, and that you literally, we still work with the Hive Metastore. So I have a blog on this specifically to alleviate this confusion. But when people see there's a Hive connector in Trino, they're like, well, why would I want to connect to a running instance of Hive? And that's actually not the case at all. When you so some connectors, like the MySQL one, the Elasticsearch one, those ones actually are reaching out to running instances of those systems. But for Hive and for Iceberg and for all these data lake scenarios, this one's a slightly different one. Instead of reaching out to a running instance of Hive, you're actually the Trino core query engine becomes the replacement of that engine. And the only thing it uses from the Hive perspective is the Hive data model, and it uses the Hive Metastore. And eventually that might even go away when we start moving into Iceberg. We're looking into replacing the Hive Metastore. Obviously,
what about track stack?
Yeah, so we're actually looking into JDBC catalog, and there's a lot of work going on in the Iceberg community to kind of push towards a possible replacement for this. Now, the hard part about this is you could technically add the JDBC catalog today, but it's more of a toy today. Today, it's good for proof of concepts, playing around, sandboxing the data, but having a good catalog service that can run across Spark and Trino and Flink and all the different ones that use the Hive Metastore that have built around it, it's going to require a little more ingenuity. And I think there's some work going on in the Iceberg community going on. I haven't been following it too much very recently, but we do want to support the JDBC catalog to, at least from a onboarding perspective, we can take off some of that. And ideally, at some point, this JDBC catalog totally replaces Hive Metastore. And all the JDBC catalog is going to be is literally this little library that sits on top of a Postgres instance. So you'll just have Postgres, because Iceberg at the end of the day needs a compare and swap method to be able to support the ACID capabilities that it supports. Yeah. So to have that compare and swap, you need to have a database that.
And a question about it. Any thoughts about just moving also and granting the capabilities to S3 to have that? Because we know that Auto Connectors has this capability to use a Metastore on S3? Any plans? Do you think is going to have any plans in the upcoming future?
So, like, open source Metastore is going to be Hive Metastore, I think, for the ongoing thing. And then that will be replaced by the JDBC catalog that Iceberg's using. So you could run that on your own eventually. But for now, if you want to run an open source catalog manager, then that's going to be Hive Metastore, unfortunately. Or there's other options, which is, if you're in AWS, you can use Glue. If you are using Starburst, we have our own internal Metastore that we use. Essentially, we just basically say if you can opt out of using a Metastore, and then we essentially just use one internally. So there are options depending on what you're using. I think. And of course, if you're using like Athena or EMR versions, then you'll also be able to use the Glue catalogs. But yeah, so in summary, kind of like those are my two big use cases, right? Like you either are using federated or you're using kind of like it as a data lake query engine, and the data lake query engine can then be broken down into other multiple things now. Getting into the tardigrade stuff, I don't know if we want to hop onto that next.
We are almost there.
Okay. Well, anyways, we'll put a pin in that, but there's two like types of workflows that you'll do on a data lake query engine, and we'll talk about that here in a minute.
Perfect. Yes, Mateus.
Yeah, one of the things that people always ask, and myself as well, I saw a lot of updates during this last month. I was crazy. Almost every week I saw like, okay, new release, new release. And I like you to highlight a few releases that we can see in the future of Trino. Like this function is something that we're working on, but we still don't have no need to work on deadlines. Want to know, okay, we work on that. Which connectors you are trying to deliver? How is this roadmap?
Yeah, so a couple things that are floating around, and again, we're trying to get a better consensus on like what people like can expect, but it's always really hard in open source because nobody's working full time. We obviously have Starburst people that work a lot more heavily on this, and we have people from Amazon that work really heavy on this project, and people from Lyft and everything. But they're at any point they could have something that becomes more important priority, so that always gets pushed off. So I think thank you for kind of not saying the no deadline, but I want to also qualify why there's no deadline is because these are people like myself, like a lot of you, that dedicate your own time onto doing open source. So please be, gracious and know that we're doing our best in getting these things out. But here are things that you can start looking for and kind of getting you're looking out for is essentially. We started releasing, so very recently we talked about Java 17. So now we have migrated a lot of the kind of the recommendation to in the whenever you compile and things like that for you to require Java 17 to actually run it. You can still run Java 11, and then I think very shortly in the future we will be requiring Java 17. And this is this comes with significant. I have a Trino community broadcast I can link you guys to. Significant performance increases and performance boosts, particularly around time taken in garbage collection. Different kind of methods that they do around I/O and all this stuff. Just a ridiculous amount of fixes. So moving to Java 17 is huge for us from a performance standpoint. It takes a lot of the overhead around garbage collector out. And then another big one to look out for from the performance standpoint. And again, this one we have some of the 4 early things released for this. So usually what happens, by the way, for the release process for Trino is you'll release kind of like the core capabilities, like interfaces and things that need to be on the core engine first. And so we call that like just support for like adaptive query planning, something like this. And so that's just meaning like nothing that faces the user yet. It's all stuff that's like very internal to the system and nobody's going to know about yet, but it'll get released. And then like people are like, oh, is it here yet? And they're like, I'm like, no, that's just like the needle. And then like we need to start pulling the threads through it one by one. So we're very methodical in terms of how we add these things in, because you want it to be very clear from a historical perspective, looking at the Git stuff to like see how things historically got added. And this is why things in open source take long as well, making sure the code is quality still. So we've added the kind of a lot of the internal support for adaptive query planning. And so what adaptive means is, so like when Trino gets a query, a SQL query, it parses it, makes sure that it's correct in an analyzer, and then it basically starts building a plan. And that happens at query time. So like at the query time, it comes up with a plan, it sends that to the scheduler, and the scheduler runs that plan, no matter what happens after, right? Or unless you have the ETL capabilities running, like, or fault tolerance capabilities running, you might crash, right? And that's just what Trino does. And it uses all the resources until it either can't or it's done. And so literally that's how Trino will run this state. Now, what we're moving towards is we want to do what's called adaptive query planning, meaning in the middle of the query, if you start to pull from, like, let's say one of these partitions, and you have like a customer that's like your one main customer, and that is constantly skewing your data, well, then now we can actually have the query start splitting that customer data, and it realizes, oh, this one partition is like 5 times bigger than the other through like 4 partitions that we have. So we need to split this partition into 4 more partitions and split it out.
Oh my goodness.
So
at execution time.
At execution time, it's running and figuring this out and doing these little like pings, and it's all happening. I mean, it happens. So I think some people will hear this and go like, well, that's a lot for it to be doing at execution time. Like, that's going to be a lot of chatter or something like that. But it's surprising. So all of our, query parsing, all of the planning, everything happens in literally like under milliseconds inside of the coordinator. And it's happening multiple requests hitting it at a single time. So you got to understand that, like, there's a lot of code that goes into the planning stuff, but the actual time it takes to execute, like the decision making for the query planner, is very fast. And so executing adaptive planning is also super, super fast. It's the I would say the part that takes the longest is actually running the kind of statistical modeling, or whatever you might want to say, like the kind of getting the stats on, oh, this is a big freaking partition. Let's start moving this into like separate splits and start making this, distributing this partition over multiple shards and things like that. So that's kind of where one big thing that we're really excited about, really looking forward to, because a lot of people have been talking about like, oh, are you guys going to do this C++ vectorization stuff that like Presto's doing? Or are you guys going to do all this like, or Photon is another one, is the Spark or Databricks people are releasing Photon. It's like C++ vectorized query engine, which is really cool. But it's like, they're like, oh, are you going to change to that now? It's like, no. It's like, this has been a 10-year project that we've been writing in Java.
Different ways to skin the cat.
Yeah, exactly. And there's all sorts of like advantages actually that you get by staying on Java from a product and growth perspective, right? Yeah. And a lot of people think about it just from the bare metal speeds, but you actually, like, that doesn't affect you. What actually affects you more is being able to do things like adaptive planning. That I always like the kind of analogy I draw is like, you have a Usain Bolt, and then I always Johann Blake. He's the second fastest man in the world, right?
So
if you have like, okay, something that's written in Java and C++, it's such a minimal, like, at the end of the day, it's such a minimal amount of like nanoseconds, milliseconds that is the change. So it's essentially the difference between Usain Bolt and Johann Blake. And so, would you want to have Usain Bolt doing a 100-meter running in the wrong direction, or would you want to have Johann Blake running in the right direction? It's like, that's essentially what you need to start focusing on, is like making sure that your query engine is producing optimal plans, that you're pushing down the query as much as possible, so that the underlying query engine or the underlying database that has its own query engine and its own indexes are being utilized, and not doing everything into Trino. If you're doing that properly, that's actually going to be the bigger benefit versus thinking through, like a language thing. So this is something that we've been really heavily focusing on, and that's something to look out for. Hopefully, I'm not going to say release date, but it's like fall time frame, maybe winter time frame. Start looking out for adaptive query planning. It's going to be a game changer.
That's going to be the new kid on the block.
Yeah. And then one more thing I would say is we just released polymorphic table functions, and that's a mouthful. So I'm just going to remove polymorphic and ignore that I just said that. Just call it a table function. And what these allow you to do is you can actually, so far what we've done with these is we've allowed full query pass-throughs with this. And what that means is that, back to the Elasticsearch example, if you want to actually send Elasticsearch like, a query DSL, like a full-scale query DSL, you can actually send that directly to Elasticsearch, and it's going to actually, with the table function, you're actually able to send that raw Elasticsearch query and get back an actual table, and it's going to determine that the shape or essentially the schema of that table at runtime, and then be able to synthesize that inside the query. Now you have to obviously know at least one or two columns, maybe if you're going to do a join before that comes back. But as long as you know how that column's going to be set up, then you can actually do a full pass-through query, essentially a raw Elasticsearch query. Because remember how we were talking about you can't perfectly, you can't perfectly match, what's going on in Elasticsearch to a SQL query, but with this full pushdown capability now, you can totally do that, and it's going to, at runtime, figure out the schema and be able to return that. And that's the thing, that's the novelty of it. And this could extend far more than just raw pushdown queries. This could go further into things like being able to run Python scripts to transform the data into different forms. So a lot of people really like kind of Pythonic, adding Pythonic expression to kind of in their data pipelines. So, Trino traditionally tries to stick to everything through SQL. At some point, it might be that we have something like, PySpark or something where we are able to do it kind of more externally. But for right now, being able to, with, polymorphic table functions, being able to kind of embed languages to run there, or even bigger things like internally, just being able to kind of like dynamically determine through, some like dynamically determine the shape of a returning table is actually something that can change things internally to the query engine as well, and have like a lot more optimizations under the hood that we haven't even really like thought through yet. But polymorphic table functions, and there's a blog on this for if you don't know this, but it's going to be a very huge game changer. It's going to set Trino pretty well aside, and I think a lot like no other big data system has worked with polymorphic table functions. So kind of the design space there is very new, and so we're kind of, I would say we're very much pioneers in the big data space to be doing this. A couple, MS SQL and all these other kind of established databases have done this, but yeah, we're the first ones kind of in this space to be doing that. And I'm really excited to see what that actually holds for where we go with that. Where the community, once they get kind of understanding what polymorphic table functions are, what they can do with this and kind of suggest to us, because it's actually
leverages.
It's a very generic and very powerful function. So that's already landed. We've already had some example use cases of pass-through queries, but it's only, that's just the beginning. It's just like just starting right there.
Wow. It's just crazy massive. I mean, those two that you talked about, the get query execution and the polymorphic table, yeah, definitely we're going to have to take a look at it.
Yeah.
But now let's just take a step back and think a little bit about the use cases that Trino just, take. I know that there's a bunch of them. We can just pretty much use Trino for a bunch of different variety of problems, not only on the data engineering spectrum, but the software, the machine learning stuff, so on and so forth. But if you would pick the low-hanging fruits, what would you list as the ones that they really hits the road?
So obviously, if you are, one I mentioned before, if you're on Hive, you should go to Trino. If you are, if you have a scenario where you need to join data across multiple systems, you should use Trino. If you are experiencing very slow query latency over, your current data lake, however it's set up, you should use Trino. Like those are, to me, just the no-brainer ones. Like use Trino for those. Now, In the cases of like, so federating data, back to those two core use cases, federating data, and then querying data on a data lake. Those two are like no-brainers. Next ones I would say is like, we're starting to move into the space, and we recently worked on these fault tolerance capabilities. Now, fault tolerance was like a highly debated feature that we've been thinking about, because we've traditionally avoided fault tolerance because Trino is pretty fast, so fast that traditionally most of the time, if you had a query fail, so essentially a query typically would just run out of resources or memory. You would be throwing enough queries at it at a time, or a certain query would be a resource hog, and then you would eventually run out of memory, and it would have to kill. Essentially, Trino would just know to have to kill the query. So the queries were typically minutes versus hours versus all these other problems that you have with like other big data engines, that the penalty that you'd have to pay to resubmit is usually not too much, unless we're talking about like high ETL batch data that is like taking that even in Trino sometimes could take, a couple hours versus, half a day. But like, so it's still, Trino may be faster, but it's still taking hours to complete this query. And that's going to depend on the query shape. It's going to depend on the source. It's going to depend on how far away things are, in terms of geographical location. It's, the data, the data, egress fees. That's what I was trying to say. I was like, egress. The data egress, time that you're spending on egress. All of that stuff is going to factor into like, how long a query takes. And so if you start getting on the higher order of that, that's where people started to feel less comfortable using Trino for longer running queries. And we heard for a long time, like that's what people want, is the ability to, it wasn't so much like, they would want to basically use Trino for everything and not have to kind of shift back and forth between Trino and Spark. Because you then have to shift, your SQL queries. You have to shift over, every time you write anything, you have to write two versions of it, and you have two places for people to go. You have to maintain two systems, and so unless you're Facebook, where you're no matter what, you're going to maintain those systems. Like, or if you're like, even a slightly bigger company, you might have Spark anyways, but. If having more than one system, if you can just narrow it down to one system, we want Trino to be that possibility, to not only just be the fast query engine that gets latched onto Spark, but we want to be the one that you can use for pretty much everything, so you don't have to run.
Use cases.
Yeah. So the ETL, use case was always one when you started getting to a certain level, lower order ETL, that would take an hour or so. Yeah, you just resubmit the query. It's fine if it fails. And most of the time, you just wouldn't even have that problem as long as you're paying attention to your resource allocation. But then when you started to move more into, these bigger ones that could just have bursty, like, oh my God, all of a sudden this query became a resource hog and it came out of nowhere and it shot the whole system, right? People didn't want to be on call and be waiting for that call, right? So we wanted to have that option. And so we had a guy actually who just came from Facebook and the Presto community, Andre. He had implemented the Presto on Spark solution, and he really wanted to have a native version of that, not depending on Spark, that could, actually live inside of a Presto or Trino, And so he that was the first project. He was like, everybody was like, yeah, Andre understands this problem space very well. He's very commonly worked with Spark and Trino. So he was like a very clear contender to be leading that effort. And so he started working on that. And, I think only within 4 months of him starting on Trino side of the project, he had an initial release. We started trialing out with a couple different users, and we had really good results. And we're already seeing like a lot of excitement around using it. There's still a lot of space of where we need to optimize. Recently, we did make dynamic filtering, which is this. It's a special way to kind of make Hive queries or data lake queries run faster. I'm not going to get into the specifics of it, but it's very important that runs, because it's going to potentially slow things down if you don't have that running. And we have that now working with tardigrade as well. So like just opening up all of those avenues that we had with the previous query engine running mode, but doing that with tardigrade now is also another kind of like thing that's very much in progress right now, and almost, I would say, getting to closer to being, not done. Nothing's ever done, but it's getting to a really good spot.
To general availability. But the question that I do have about the tardigrade, it's something that's going to be a flag, or it's going to be automatic. So the query by itself, or the scheduler, someone is going to understand that this is a long-running query, or you're going to have to set a flag and just specify that.
Yeah, you want to set a flag. So by default, we disable this functionality. We want Trino to still be the fast query engine, but what we've seen is a very common use case. We have people who are there's this project called Lift Presto Gateway. Is Lift open up this one called Presto Gateway? Now it's actually working on Trino. It doesn't work on Presto anymore. But if you use that project, it's basically a proxy or kind of load balancer that can go over multiple Trino queries. And what's very common that people do is, one, they do a couple things. They'll use it as a proxy so that they could actually load balance over multiple Trino clusters. So if you want to essentially have like you don't want to have one cluster that could potentially go down, and then when you're trying to do updates, you could take one cluster down and it's not going to kill everybody's query essentially. And so that was a very first common use case for this thing. But then it expanded into a routing. They added a routing capability to this so that companies that wanted to do something like, okay, if you're this type of workload, like say you submit a query and you know that you're a certain type of workload, then I'm going to route you to this cluster. And if you're that type of workload, I'm going to route you to that cluster. Now, before we even had the fault tolerance stuff, people were still using Trino for ETL. What they would do is they would just soup up the resources really high on these ETL clusters, and then they would have a couple smaller what we call like interactive workload clusters. Those interactive ones would be like, hey, I have a very small like query that I need to run across 3 databases, and it's just not going to be that much data. Okay, we're going to throw that one to the interactive query engines. But then, I have this one. It's an ETL job. It's going to take hours. So you throw that one to the big marbles, cluster that's really beefy and is able to handle that. And they know how to tune it. They know roughly the workload to expect, and that was typically done pretty well. Now, essentially, you just have the option. For those heavy resource type of workloads, those heavy resource queries, you can just those other 2 interactive ones can stay interactive, because you don't want to have to pay the penalty for smaller queries to have to run the fault tolerance stuff. You don't want to have that fault tolerance overhead. So essentially, the other one, the big beefy one that you have, you keep it big and beefy, but now you can actually flip on the switch to say, hey, this one, in the event that this one's going to be running, 2 or 3 hour long queries. Like the overhead that we pay for the fault tolerance is really minimalized by the runtime of the query. And so everything that gets sent to this one, run the fault tolerance and make sure that, essentially that this doesn't crash. And with that experience from the user end, if I'm running a small query, I get it back super fast, because I talk to the
same thing as usual.
Yep. I talk to the small Trino cluster that does not have fault tolerance enabled. If I'm running the big marbles, I'm running a really big ETL, type query, boom, that's going to go up into my big beefy cluster that has fault tolerance enabled. I can sleep really calm at night, because I know that if we do run out of resources, or one of these, basically what will happen is if your query starts hogging resources, we're basically going to tell it to back off. And basically say, wait, we're not going to kill the existing work that's been done on it, but it's still going to kind of process, but it's going to kind of slow down one side, and it'll clear out some more so that it can actually progressively, tackle that query. And so that ultimately solves the problem of, okay, now I can have these couple fast clusters, and I have my kind of like ETL cluster that's going to be, relatively slower, but still, when you compare it to a lot of the engines out there, right? It's still faster with the fault tolerance enabled. So
interesting. Wow, that's going to be impressive, because I think that's you made a good point. between switching gears between different technologies. There are times where you start to use Trino for a variety of use cases and start to feel pretty happy about it. And then there's just minimal edge case that you have to run a query that's going to take more than hours. And then you stop to be on the technology that you love because you have to flip to another one. So I think that should be a pretty fantastic case. Even though for long-running queries, I think it's going to be a pretty much match made in heaven to see Trino and Airflow working pretty well.
Yeah.
Because this way you're going to be able to orchestrate all the queries, and you're going to be... And I know that there's a bunch of work happening there, and there's a provider for Trino as well that already works.
Just started,
So I'm super happy to see that running. My next question will be, I promise that I'm not going to say too much here because we exceeded 1 hour, but because it's been amazing, I'm just having like one of the best sessions ever here in the podcast.
Me too,
honestly. The amount of details and the things that I explain is just crazy. Just pretty much impressive. Congratulations on that. But we love that thing called Kubernetes. I think that's the cornerstone of each one of the solutions. For people that never heard about it, which I think it's going to be pretty much impossible, or think that that's going to be the next momentum of the technology, you guys are totally wrong, because Kubernetes is taking the road. And everywhere that you go, in any company, in any size or shape, you're going to see Kubernetes running underneath and behind. Because it's the infrastructure cornerstone. And I know that there's something pretty fantastic called Trinets. Tell me about it.
Trinettes. I was a joking like little title. I always have goofy titles. So when I make my Trino community broadcast, I hope people get a giggle out of that. At least I do. So I do too. Okay, good. So at least I have one giggler. Thanks, Luan. So Trinettes was kind of the title that I just merged Trino and Kubernetes. We've really, at the time that I even came out with the first episode, we really didn't even have the full Helm chart support yet. We were using a community driven Helm chart. That, when I say totally community driven, it was just some guy in Italy that was Valatoriano. He was just like, running this whole basic project by himself, and everybody in the community was just starting to use his version. We had like a very minimal version, but it wasn't receiving a lot of love at the time, and we wanted to basically get it merged in, but his initial PR was just like this giant pretty much his whole project was just getting merged into our original Helm chart and taking it over. And it was a lot to be reviewed, because again, I was kind of mentioned before, we like to start very small on these like little root cause cases, and slowly iterate, so that from the Git history you can kind of see how things evolved, and it's like at working very, very well working at each commit essentially. So we were trying to get that merged in, but we didn't have anybody paying attention. So I was like, okay, I'm gonna make this community broadcast and just see how many people react to it. And it got such a good response from the community that I think it did a little bit of help in motivating the people to pull together and essentially get the Helm chart merged in, split these things down, and then ultimately we've now merged in Valeriano's a lot of his original functionality, and now we're adding more and more on, and people are writing more blogs on how to use Kubernetes Helm chart with Trino. And they've even added cool monitoring solutions on theirs. It's crazy how people are growing their things that they needed in their particular use cases. And it's I saw this one blog yesterday. It was just this guy took the Helm chart, pulled it up, and then added a separate Prometheus cluster to monitor things going on inside of Trino. So yeah, he's his whole goal with the blog was I want to bring up Trino, but I want to be able to see the JMX things going
metrics.
On. And how long are these? All the metrics, right? And it's super important, right? And we have some metrics that sit inside the Trino UI, but it's definitely not full-fledged. It's if you want to have every metric under the sun that we actually track inside the query engine, it's definitely worth, bringing up JMX, bringing up Prometheus, and having visualizers for that. And so I was floored by this person's initiative to share that with the community. So that's really exciting. And so we have a Helm chart now that is very much heavily getting more and more in use, and I would say is the de facto way. We're writing up better documentation on it right now, just so you know. And I'm going to be writing up a lot more tutorials now that, again, those initial Trinities videos were kind of like icebreakers and letting people know that it is possible. Here's how you would kind of like bash it together. But now those are like already outdated. That was it was like a year ago that I did those. And, it's like, in this last year, the Helm chart and the development around the Helm chart has just skyrocketed, and we've seen a lot of community coming in around that and building it out. So it's a whole different experience now. We're building out documentation. We're going to have that in a lot more of like getting started type materials, and because like originally I have a Trino getting started repository that's like all in Docker Compose, and we really want that to be something that we really want that to be here. I'm going to start this over so that we can cut it out. Okay, so we really want.
No, that's all right.
Oh, okay. I was just saying, so for the edits, you can do that. So we really want the the Kubernetes to be the kind of de facto way that people approach even getting started with Trino, because that's Tarball and Docker are kind of ways, I think, to even like play around with it a little bit or get it into a custom setup if you have one. But most people, I would say, across the industry are following the Kubernetes standards. And whether it's Kubernetes specifically or not, there are standards around it that you're following. And as long as you follow those, you should be able to use the Helm charts and and all of the essentially the core like YAML structures that we generate with the Helm chart. So that's how you deploy locally now. That's how you deploy in the cloud. That's how you deploy. When I say locally, I meant to say like on your own clusters. And that's also can be how you deploy on your own like laptop. And it's the same thing once you learn it. You learn it once and then you're done.
Yes,
and
I
it
agree.
Scales.
Totally agree.
And it scales.
Yeah, and it's crazy, and it scales. Yeah, I do have. I think that we do have 3 last questions. Do you have time to?
Yeah.
Get them. Okay. I have 2 questions, technical questions about some connectors that I would like to have more, I would say, enlightenment.
Sure.
So the first one is about the Kafka one. So we do use a lot of Kafka here, and we started to try some tests on heavy clusters on Kafka with billions of events.
Yeah.
And because of the Kafka way of storing data, it's a log appending only. I don't see any way for you to query intelligently if you have to query everything, because you have to run everything from start to end, and you have to go over the log, write it down, just bring that up, and just make the query over the fly. So for that, what we used to do is that we just put Pinot on front, and then we use Trino to query that thing. Question: that should be the follow the sun approach, or do you guys think you can do anything around Kafka? Even though I don't think it's going to be too much possible, to be honest, but I would like to hear if there something on that spectrum.
Yeah, I've been looking for real production use cases for Kafka, in the Kafka connector, I mean, because it's always, I never used it myself in my own work. And when I got here as an advocate, I wanted to figure out how people were using things and doing things. And I found a couple people that say, and I didn't really get too much follow-up on how they use it, but I'm hoping at some point there is one individual, his name's Kobe, he's in the Tel Aviv area. He was really interested in trying to extend out the use case, and he already has a use case around Kafka, but I haven't really got to dive into it yet. But I told him at some point I want to bring him on my show just to kind of understand that a little more. However, I would say for the most part, if you're wanting to do real-time ingestion using Pinot, Druid, ClickHouse, something along those lines, and that's maybe more. I can't remember if ClickHouse is real time or near real time, but it's very fast, faster than a batch system like Trino. But if you're wanting to do those, I highly recommend Pinot and Druid and whichever one's your flavor. And go ahead.
Now, just to elaborate a little bit, because I would like to use this moment to give you a little bit of background
Sure.
for you to understand the whole scenario. So basically, in a microservices scenarios, we do have to plug the microservices alongside with the data engineering spectrum. So imagine that I'm publishing data inside of Kafka, right? And I have Trino. But the problem that I face right now is that if I would like to interact through this new row that appended, I have to read the entire log. I don't have the capability to simply consume the last appended, because I'm just always starting from earliest instead of starting from latest. So if I would have that flag on Trino that I would query only the latest append log only from the last append that arrived, that would be fantastic, because I would read only the differential data. And then I would interact over that.
That's definitely something that, if that, I mean, I'd be surprised if that maybe doesn't even already exist as an issue and nobody's just implemented it. Because again, I don't see Kafka as the common way that people use it, but I do think that, that I don't imagine that would be a very hard implementation. That's very much just updating how you, you would have to expose essentially a property and then update how you propagate that down to the client, right?
That's it.
And so I wouldn't imagine that'd be a hard change, but it's just about, I would check. I'll follow up with you on that.
I'd love to circle back on that. I would love to circle back on that, and maybe we can come up with something.
We can essentially search, the issues log and see if anybody else has asked about that, and then create an issue. And then after that, it's like if we get enough people, I typically tell people when they want a feature, just get the community behind it and we'll do it, and that's literally what we do. And so but first step is always creating an issue. And then the second step is to get everybody to believe that your issue is important, and I'm not saying everybody's like kind of has like a lot of issues that they believe are like their importance. And it's like the squeaky wheel is the one that we can get to. Like we want to believe that everybody's issue is important. Another thing that's possible too is if you do know Java, I don't know, if you know a Java, the implement it, you could also go and implement that and pull the PR, and then that's definitely like we're always happy to get the PRs for that. But I know not everybody knows how to do Java specifically. A lot of people are more Python people or Go people, and so it's like if you don't know Java, then that's like one of those limiting factors to contributing to Trino, unless you just want to learn, but nobody has that time, right? So and in that I would say, just get people behind it. And then if you have enough people kind of like, asking questions about it, because we do, I'll get you in touch with somebody who is also very interested in the Kafka connector. He might even be already working on this, as far as I know. And his name's Kobe. So
please do that. Please do that. So I would love to circle back on that.
I would say canonically, how I see people doing real-time stuff in general, there's two things that I see is that people, particularly when they're using Kafka, is the one that you mentioned with Pinot or a Druid or something. The other one is I see very commonly coming up is change data capture and CDC. So this is now becoming more popular where upstream transactional systems, you need to just capture the changes, the deltas. And so change data capture is super cool because it offers a model to take it's essentially an extension of a write-ahead log in a database, and it's just putting it on Kafka instead. And so now your write-ahead log is not only inside of your database, but that write-ahead log now gets modeled in Debezium or whatever CDC that you're using, and that gets pushed across Kafka, or I think it even doesn't have to be Kafka, but I think the common way that people implement it for like backing their data up and stuff, or redundancy, is to use it on Kafka. So it gets pushed onto Kafka, and then it gets consumed by either like Debezium has like dumper, like a dump sync code that can go into like Iceberg or something like that. And there's also Flink that can pull it directly off Kafka, so it doesn't have to go through Debezium and do it in, I guess, a more streaming fashion. I don't know if that's the reason why people use Flink necessarily, but I know Flink does a good job at like, it knows the Iceberg model a little bit better maybe. I'm not sure if that's the case. But anyway, so you can do one of those two options, and then it goes into Iceberg. And at that point, what's really cool is that you have this synced transactional data in your data lake at that point, and it's actually pretty it's pretty real time. Now the Trino being a batch system, it's fast, but it's like not real time. It's not streaming, but you can get a near real time query running on this the real time is all the way up until it dumps into Iceberg, and then it's like near real time when you start querying it with your Trino system. Those are the two ways that you do it. Now, if you need full on streaming, I would say go Pinot or Druid, and then just run Trino on top of that.
Mm-hmm. Yes, that's exactly what we do actually. But we do. I mean, I'm not going to go into details, but actually, we have a specific customer that has to compute geographic information at the runtime. So Pinot, it's not. It doesn't give you the fully fledged capability for that. So you'd like to put actually. Pinot doesn't give you that, but Trino does because it extends the same Postgres capabilities. So it would be fantastic to run this over Kafka. And we have a problem because we have to read the entire, and then we're going to have to wait a couple of more seconds to get the data into Pinot after to run this computation. So it would be fantastic.
There's some optimizations coming up here, by the way, for pushdowns into Pinot, by the way, and stuff that Trino can do computation-wise that will become, I mean, this is going to be as close to real time as you get, but basically a lot of the computation is very well pushed down into Pinot. I need to hook you up with Elon. He's implementing all this, and he does exactly this thing on Pinot. And so Elon Azule he's done a lot of the implementation around Pinot Connector. He's adding a lot more, and actually we're doing a talk on this in the real time data analytics summit in September.
Okay. I think we can just move to the next question, Mateus. Just I would like to hear what Brian has to comment about community.
Yeah, this is your take, Brian. I like to know, and switch gears about technical to go more about people. I see you working a lot with communities. Do you see that we even talked that before in the backstage, like a few weeks ago? And what your take about the community be the road to success for the professional? Do you think it's worthwhile participating in communities? How do you take on that?
Yeah, I mean, this is going to be preaching to the choir, I assume, but it's like community is literally the way to do anything these days. I think there's so much strength when it, especially around, we've seen a lot of it around open source, but it doesn't even have to be open source. It can be really into, I will just be divulged like what you both are doing, in particularly the like Latin American, or I don't know if it's just Brazil or if you guys are expanding out to Latin America, but in the data engineering communities there, there's not really clear roadmaps for people. It's getting better for data engineering, but it's just like the world's hard, and it's hard to be in this fast, ever evolving world. And sometimes it can be very isolating to if you're working somewhere and you don't always get the best luck getting on a team that's going to teach you everything, finding a company that's going to work on your skills. And sometimes you don't have the ability to even have access to have a degree or school or anything. So having community for people who traditionally just wouldn't have access, I think a lot of times about, working moms that want to improve their skills, or disabled people, that like particularly maybe can't access going to a conference, or, even people who are at their current job and they just struggle with anxiety and they don't feel comfortable talking to their boss or, getting training and things like that. Having an online community and even community where you go meet up with people, it takes away a lot of this stressful environment about, work and having to show up and be already a genius at everything. And it lets people kind of more comfortably share these ideas, share how they do things. There's a lot of space for mentorship and for people to really, grow in that way. And I think that community to me is just like, and offering spaces where people can kind of have this is where I think the future is in terms of, the workforce where we start to see, better, I guess, happiness around what we do as humans, because we do this stuff a lot of our days. And so it's actually good to we're a social species, right? We don't, same thing. I kind of told you on this backstage, but this was during the interview. one reason why we shifted to the lighter, friendlier brand of Trino over, kind of the old Presto brand that was a little more abstract and computers and, less human or less cute bunnies and stuff like that. We want to really emphasize the humans at the center of all this is, people that come into open source projects or communities, it's all needs to be centered around the individuals and kind of the collective needs, as well as even individualistic needs, making sure that people feel heard, feel seen, and actually are able to contribute and feel that their contributions are valued. That brings a lot to just not only us as like a data space and growing our technical skills, but it just brings a lot to humanity, right? In terms of being good kind of people to each other, good stewards of the earth and our fellow humans and our fellow, beings. And so I get very philosophical when it comes to community and how I view it and how I view people being in these spaces. And, it's very important to me that we have, people, a space for people to kind of feel welcomed and heard and that they can improve themselves.
And feel belonged, and I think I couldn't say better than that. So yeah, spot on. Amazing. But I think this is a wrap. Brian, my take is that I had one of the best moments. Just interviewing you was fantastic. I think your energy, enthusiasm to talk about Trino makes everything way better. Trino, it's amazing, but then just getting someone from the dev relationships or advocate that can speak with passion and love, I think that's the different approach. So thank you so much for your time, and I totally hope to see you in the next episode to talk about different things about Trino can achieve and do. And it was a pleasure, and you can count on us. And of course, we're going to follow up on the Kafka and Pinoy stuff because we are super interested on that.
Yeah, thank you so much for having me here. This has been great, and I hope this helps the community in Brazil and South America. I have a lot of family out in Colombia, and so hopefully this helps everybody out there. So learn a couple things about this amazing query engine that we all know and love.
Amazing. Thank you guys for the great episode. It was amazing. I'm speechless. I'm digest all the information, so I'm still I'm offloading the information. But yeah, thanks. It was amazing. It was amazing.
Great. Okay. Well, I'm looking forward to a great episode, and talk to you all later. And just let me know whenever we can plan the next one.
Of course. See you guys. Bye bye. Thank you so much.